Alright, sorry guys, I've been away for so long. I've just been very busy lately, and I've been studying a lot, but I've just been thinking about this problem 14, aka the clock block problem of the 2015 AMC 10A. This involves a clock, and you would want to know which position on the clock will this circle still be pointed upwards. So this got a lot of incorrect answers, and I can see why it's very tricky. One would think that it's D6 o'clock, but it's not, and I can show you why and how you would go by approaching this. And yeah, I've also gotten this one wrong when I tried and practiced it, and then after just thinking it just about now, thinking about why I got it wrong and what is wrong about it, I finally found a simple-minded and very simple approach. So imagine that this is a circle of 2r and this is a circle of r. So keep in mind that some of these two distances are equal, but they're not the same. As you can see, this circle will go out farther and then will take more time. However, this circle has like a curve, so when this circle curves, it will be a lot steeper. And for a more extreme sample, you can imagine some circle like this, and then just a very steep slope like that. Now already at traveling here, it's going to be something like here. And this is like very slight. So this is just like an example of how this arc will affect it. So you might think that it's very difficult to approach this and there's a really clear correlation between the two. However, one thing that can really help, just draw a tangent line. And now the problem has just been simplified a lot easier. So what your goal is you're gonna try to achieve the total rotation should equal to 360 degrees. So that's what you're trying to get, the total rotation of 360 degrees. You know that as you rotate here, the angle of this one will make this circle, or the angle of this circle will make the angle of this circle greater than on a straight line. So now this line just actually helps to visualize a lot, and you'll note that the angle of this arc, the total rotation, will just be the angle of the arc. So will be the angle of this arc and the angle of this arc. And the reason why is because if you just rotate on this line, you can see that it's just the angle of this arc alone. However, you're trying to have a rotation over this angle. And how do you measure that angle? Or yeah, essentially you're going to do it over this angle. And that angle is just simply the arc. Because if you think about it, it's just the angle of this, which is just going to be that arc, plus the angle of this, which is just going to be that arc. So that just helps to visualize a lot. And now you're just going to try to achieve the total rotation of 360 degrees. So essentially, we're going to try and look at the answer choices and try and figure this out. So we have one at 2 o'clock. So let's just say 2 o'clock. So the one at 2 o'clock, that's going to have an arc of, I believe, what is this? Oops. This is going to have an arc of 60 degrees. I think, yeah, 60 degrees. And now we're going to try and convert these degrees into the degree for this one. So we know that this is going to give approximately, what is this? This arc is going to give you a length of 40 pi over 6. And since this has a circumference of 20 pi, then therefore you would need to have 120 degrees, or you need to have an arc length of 20 pi over 3, which is just equal to 40 pi over 6. And that's just simply 360 degrees divided by 3, which is just equal to 120 degrees. However, you'll know that 120 plus 60 is not equal to 360. So we're going to have to move on to number 4. So basically what you're just doing is you're correlating arc length with degree length. So now moving on to 4 o'clock. It's just a lot of reversing. Sorry about this. So this is going to be 4 o'clock, and obviously that's just going to be 120 degrees, or the whole length of this divided by 3, because 4 is just 12 4 is 12 divided by 3. So 120 degrees is going to give you an arc length of 40 divided by 12, which is equal to 20 degrees divided by, or 20 pi over, it's going to give you an arc length of 40 pi over 12, which is equal to 20 pi over 6. So now, wait, 40 pi over 12, oops, sorry. 40 pi over 3, I don't know why I'm making all these mistakes. 40 pi over 3. So now it's going to be a little bit tougher to correlate this. But we know that 40 pi over 3 is just going to be 2 over 3 times 20 pi, which means that this would give the total amount of degrees is going to be 240 degrees. So we know that 120 degrees plus 240 degrees is equal to 360 degrees. And therefore B, 4 o'clock is your answer. I believe B, oops. Sorry, I skipped over C, 3 degree or B, 3 degrees, but it's going to be C. And yeah, it would still give you an incorrect answer if you had 3 for 3 o'clock. So basically, you're just trying to find angle rotation of smaller circle. This is basically just a summary plus angle of rotation larger circle is equal to 360 degrees. So this is just basically the main part of what you're trying to find. And yeah, if you're able to just identify the relationship between those two, then these circle revolution problems will be a lot simpler. So pretty much note, if you want to solve, if you encounter another of circle revolution problems, just note, just somehow try and correlate the angle of rotation of the smaller circle and add them up and make sure that they're equal to whichever direction that you want the arrow to point at. So yeah, and hopefully you can apply this to other problems, because I know that this is quite a quite a common problem in the SAT math. So yeah, thanks for watching.